Dear students, in this lecture, we are going to discuss about the standard limits. In the previous lecture, we have seen the concept of a limit and one-sided limits, like a left-hand limit, a right-hand limit at a particular point. Now, so in this standard limits, so there are some theorems with proofs and some of them are without proofs. So let's see one by one. See the first theorem. So see the statement, let n be a rational number and a be a positive real number. Then limit extends to a x to the power of n minus a to the power of n by x minus a is n into a to the power of n minus 1. So in the given statement, the value of n is a rational number only. So the rational number means that may be in the form of p by q. So before that it may be an integer also. So integer which contains positive values and negative values and 0 also. So here we shall prove this theorem in each of all those cases, like n is a negative value, n is a positive value, and n may be 0. Then finally n is a rational number. So first, so we will see the proof of this theorem in each case, like the value of n is 0, the value of n is a positive integer, and n is a negative integer. So finally, so we will conclude with n is a rational number. So let us consider the first case. So case 1. Case 1. Let it be, it is suppose n value is 0. Suppose n equals to 0, then what you have to show? Then limit extends to a x power n minus a power n by x minus a is again n into a to the power of n minus 1. Then the value of n is 0. See, limit extends to a, then so it is x to the power of n minus a to the power of n by x minus a. Now, so here the value of n is 0, right? So this is a. So if n is 0, therefore it is x to the power of 0 minus a to the power of 0 divided by x minus a, means it is 1 minus 1, so 0. Now so this 0 that can be written as 0 into a to the power of 0 minus 1. So why I am writing this 0 into a to the power of 0 minus 1? So we need to show this as n into a to the power of n minus 1, where n is 0, right? Now here n is nothing but 0 is nothing but n, so here it is n is n into a to the power of n minus 1. So therefore this is true for n equal to 0. Next, so we will see the case 2. Case 2, let it be, it is a positive integer. Suppose that n is a positive integer, or n is a positive integer. Now, so this is integer. Sorry. So it is a positive integer. Then so here so we need to express x to the power of n minus a to the power of n. See, here we know that here x minus a means x minus a only. Here x square minus a square is there. X square minus a square, that can be written as x minus a into x plus a. So by using a square minus b square form. Now, so if it is in the form of x cube minus a cube, like it is a cube minus b cube, so which is x minus a into, now so this is x square plus x into a plus a square, right? So like this. Now, so if it is x to the power of 4 minus a to the power of 4, now so this is x minus a times of, now say it is x to the power of 3 plus x square into a plus x into a square plus a to the power of 3. Now, so similarly you can write x power 5 minus a to the power of 5 also. Here so you can observe the things. Now say x square minus a square, that is x minus a into x plus a, x cube minus a cube. So x minus a is a common for all the expressions, right? Now see here you can observe the next expression. Say it is x square plus x into a and a square. See here we can observe the powers of x here. Here x cube minus a cube, then this contains 3 terms. X square minus a square, except this product, then x plus a, that contains 2 terms. X cube minus a cube, 3 terms. X power 4 minus a power 4, there are 4 terms. So if it is x power 5 minus a to the power of 5, so we may get 5 terms. Now see how we need to write all those terms. Just observe. See the power of x square for each and every term. So here it is x square is there. Next x power 1. Here it is x power 0. Next similarly the other term a is there. So here it is a power 0, a power 1 and a power 2. So in the first term x power is decreasing and a power is increasing. See here you can observe. Here 3, 2, 1, 0 and a power 1. A power 0, a power 1, a power 2, a power 3. So similarly, so by using this you can express x to the power of 5 minus a to the power of 5. Now say how to express this. So this is x minus a times of so first so we need to reduce one power. So it is x to the power of 4. Next x to the power of 3, x to the power of 2, x and next 0. Now so this is x power 5 4 into a power 0, so plus x cube into, now so next power a plus x square into, then this is a square plus x into a power 3 plus a to the power of 4, like this. So similarly we can express our x to the power of n minus a to the power of n. So x to the power of n minus a to the power of n, that can be written as by generalizing to n number. So x power n minus a power n. So this that contains how many terms? This product that contains n terms, right? Since if it is power 2, then there are 2 terms, 3 terms, 4 terms, 5 terms, and it is n, therefore so we may get n terms. But so this is starts with x to the power of less of this, right? One less of this much, it is x to the power of n minus 1 plus next what will happen? So it is x to the power of then x power n minus 2 into a increase అవుతుంది. X power n minus 1, x powers decrease అవుతుంటాయి, a powers increase అవుతుంది. Now say this is x to the power of n minus 3 into అవుతుంది a square అవుతుంది. Next x to the power of n minus 4 into a cube and so on. Next finally మనకి ఏం కావాలి? a to the power of n minus 1. So the last before last but one, that is x, that will be end with x, right? X into a to the power of n minus 2. అందుకు ఇది a power n minus 1 లోట్, a power n minus 1. See here you can observe x powers are decreasing to 0, a powers are increasing to a power n minus 1, a power 0, a power 1, a power 2, a power 3, like that, and up to a power n minus 1 only. So this is x power n minus a to the power of n value. So now we will find the given limit. Now so how to evaluate this? So limit x to the x tends to a, x to the power of n minus a to the power of n by x minus a. See, if we apply the limit directly, then what happens? So the denominator is 0. Since x is goes to a, here x minus a is there. So that so we need to create a common factor from numerator and cancel the factor. So for that purpose, so just now we need to express the x power n minus a power n as x minus a into so something. Now so replace that formula here, x to the power of n minus a power n, that is x minus a into, what is that? X to the power of n minus 1 plus x to the power of n minus 2 into a plus x to the power of n minus 2 into, that is a, and so n minus 3 into a square plus and so on. So that is end with x to the power x into a to the power of n minus 2 plus a to the power of n minus 1. సో ఇక్కడ అబ్జర్వ్ చేయండి దేంతో ఎండ్ అవుతుందని. సో ఎక్స్ క్యూబ్ మైనస్ ఏ క్యూబ్ ఉన్నప్పుడు ఎక్స్ స్క్వేర్ ఏ స్క్వేర్ ఎండింగ్లో ఉంటుంది. సో దిస్ ఈజ్ ఎక్స్ పవర్ ఎన్ మైనస్ ఎక్స్ పవర్ ఎన్ మైనస్ ఏ పవర్ ఎన్. సో కంపల్సరీ ద ఎండ్ పాయింట్స్ ఆర్ ఎక్స్ టు ది పవర్ ఎండ్ టర్మ్స్ ఆర్ ఎక్స్ పవర్ ఎన్ మైనస్ 1 అండ్ ఏ పవర్ ఎన్ మైనస్ 1. సో రిమైనింగ్ ఎలా రాస్తానో చూడండి. సో డివైడెడ్ బై divided by, as it is x minus a only. So in the numerator the common factor is x minus a, so this common factor gets cancelled. Now so directly you can apply the limit now. So as x goes to a, so it represents a polynomial, right? Now so here we can replace x with a, so that it is a to the power of n minus 1 plus a to the power of n minus 2 into a plus a to the power of n minus 3 into a square plus and so on a into a to the power of n minus 2 x లో represent. Now here it is a constant, so directly it is a to the power of n minus 1. Now so this is a to the power of n minus 1 as it is plus a to the power of n minus 2 and a power 1 is there. So here the powers are same, here the bases are same, so you can add the powers, so that it is a power n minus 2 plus 1 అవుతుంది. a power n minus 2 plus 1 means a power n minus 1 only. Now here a power n minus 3 and plus 2 is there. Again it is a to the power of n minus 1 plus and so on. Now here it is a to the power a into a to the power of n minus 2, so that it is a power n minus 1 only and a power n minus 1. So already we know, so the product that contains how many terms? n terms. Now also here a power n minus 1, a power n minus 1, a power n minus 1 and so on a power n minus 1. How many terms are there? So there are n terms or n times are there. A power n minus 1 n times, so that so this will be n into a to the power of n into a to the power of n minus 1. Here a power n minus only n times ఉన్నాయి, so that we can express it as n into a to the power of n minus 1. So here it is limit x tends to a, x to the power of n minus a to the power of x power n minus a power n by x minus a is, so this one. Now you can write limit x tends to a, x power n minus a to the power of n by x minus a. So as it is our formula is this, so n into a power n minus 1 is there. Now next case 3, so this is true for n is a positive integer. Next check for negative integer. So already we proved for positive integer, right? So here now we can use this for the next proof. So let us suppose that n is a negative integer. Then we have to show then x power n minus a power n by x minus a is also n into a to the power of n minus 1. So for that so we need to consider n is a negative number. So let us consider the number n is a negative, so that it is minus m, where m is a positive value, where m is a positive integer. మనకి ఎన్ని నెగిటివ్ కావాలంటే ఇది కావాలి, కంపల్సరీ పాజిటివ్ ఉండాలి. n ఈక్వల్ టు నెగిటివ్ వాల్యూ ఉండాలి, m మైనస్ ఆఫ్ m అంటున్నాను, సో m కంపల్సరీ పాజిటివ్ ఉండాలి. So you need to mention it is a positive integer. Now so limit x tends to a, x to the power of n minus a to the power of n by x minus a. So this is, now you can replace n with minus m. Limit x tends to a, x to the power of minus m minus a to the power of minus m divided by x minus a. Now so if you apply the limit directly, then so it will be 0, denominator is 0, so that so you need to simplify the numerator values. Now so how to simplify this? Limit x tends to a. Now so here x power minus m, that can be written as 1 by x to the power of m by using theory of indices. A power minus x is 1 by a power x, right? So like it is a to the power of m into 1 by x minus a. Now so this is limit x tends to a. Now so here this is a to the power of m minus x to the power of m by x power m into a to the power of m into 1 by x minus a. Now so we can write this as a limit x tends to a. So let us take minus is common from this, so minus of x to the power of m minus a to the power of m by x minus a into 1 by x to the power of m into a to the power of m. Now So limit x tends to a, it is f of x into g of x form, so that we can apply the limit for both f and g individually. Now, so this is minus of limit x tends to a, x to the power of m minus a power m by x minus a. So where m is a positive integer. So from case 2, so we can write x power m minus a power m by x minus a as m into a to the power of m minus 1. And already second case lo prove chesam, n is a positive integer, then x power n minus a power n by x minus a is n into a to the power of n minus 1. So where instead of m is there, so m into a to the power of m minus 1. Now here apply the limit here. Now so this is 1 by a to the power of m into a to the power of m. Then it is minus m into a to the power of m minus 1 by 1 by a to the power of 2m. Now so this is minus m into a to the power of m minus 1 into a to the power of minus 2m. Now here the bases are same, so you can add the powers. So this is minus m into a to the power of m minus 2m, that is minus m minus 1. Now so we can write this as minus m into a to the power of minus m minus 1. So already we know that so minus m is nothing but n, right? So here we can replace m minus m with n, therefore it is n into a to the power of n minus 1, where n is a negative integer. This is limit x tends to a, x power n minus a to the power of n by x minus a. Then so then the given statement is true for n equal to 0, n equal to positive integer, and n equals to negative integer. Now so finally we need to check with a rational number. So that is the last case, case 4. Now so let us suppose that n is a rational number. Suppose that n is a rational number. So rational number means it is in the form of p by q, right? So p by q, where p and q are integers and q is not equal to 0. So let us say here n value is a p by q value. So this is a p by q, where p comma q or belongs to z, and q is a positive value and q is greater than 0. And so to prove here x power n minus a power n, where n is a positive rational number, by using the previous 3 cases, so let us consider the values like y is equals to x to the power of 1 by q, and b equals to a to the power of 1 by q. Enduko the next case lo kanvastundi manaki. Now so if we raise the powers on both sides with q, therefore then this will be y to the power of q is equals to x to the power of 1 by q whole power q, means it is x, and similarly it is b power q equals to a Johnson. So here so we have y value, b value, x value, and a value. So x is y to the power of q and a is b power q, or you can write like this. So this means x equals to y to the power of q and a equals to b to the power of q. Now so we have all these values. Now limit x tends to a, this is x to the power of n minus a to the power of n by x minus a. Now so this is where n is a rational number, x tends to a, then so this is x to the power of p by q minus a to the power of p by q, right? So n is a rational number, so compulsory it is in the form of p by q. Now say this is x minus a. Now so limit x tends to a. Now so here you can write this as x power 1 by q whole to the power of p minus a to the power of 1 by q and whole power p. Now so divided by x minus a. So already see here, so x power 1 by q, let it be some variable y, and a power 1 by q is also a number, so let it be this b. So let already then r you can write here also, no problem. Let x to the power of 1 by q is y, and a to the power of 1 by q is b anukunte. Then x equals to y to the power of q, comma a equals to b to the power of q. Now so you can replace all these values here. Now so limit x tends to a, x tends to a, x is goes to a, and y power q is tends to b power q, so that it is y tends to b, right? Y power q tends to b power q means simply y tends to b. So total y lo convert chestunanu. So this is y tends to b. Now so it is y to the power of p minus b to the power of p divided by x means y to the power of q minus b to the power of q. Now so this is y power p minus b power p by y power q minus b power q model. But we have a formula for only x power n minus a to the power of n by x minus a, where n is a positive integer or n is a negative integer. Now so to convert this into that formula where the power is a positive integer, now so we need to multiply and divide with y minus b. If we multiply and divide with y minus b, then so we make it like that, or divide the numerator and denominator with y minus b. See, it is a limit y tends to b. Now so here I'm writing like y power p minus a to the power of p divided by b to the power of p by y minus b whole divided by y to the power of q minus b to the power of q by y minus b. Now so this is in the form of f of y by g of y. Now so need to apply the limit for numerator as well as denominator. Now see, observe the numerator. So limit y tends to b, now it is y power p minus b power p by y minus b model. So it is in the form of x power n minus a power n by x minus a, that is n into a to the power of n minus 1, where n is a positive integer. Here p is an integer, positive integer or negative integer. So this is p into b to the power of p minus 1, right? Now so in the denominator it is a q into b to the power of q minus 1. Now so here finally we can write it as a p by q into, now so this is a b power p minus 1 into the numerator b power 1 minus q. So finally it is a p by q into b to the power of minus 1 plus 1 gets cancelled, so it is finally p minus q. Now so here we need to express this as p by q into b to the power of p by q minus 1 model, p by q minus 1. Now so this is a p by q into b to the power of, so here I am multiplying and divide with q, so that it is p minus q by q. Then so finally this is a p by q into, so it is a b to the power of q whole to the power of p by q minus 1, right? P by q minus q by q is minus 1. Now see, already we know p by q is nothing but n, right? So we can express this as n into b power q. B power q means a. B power q is nothing but a, so that it is n into a to the power of p by q is n minus 1. So this is n into a to the power of n minus 1, where n is a rational number. So the given statement is true for all rational numbers, hence it is proved. So the next second theorem, the limit x tends to 0, sin x by x is equals to 1. So here, so we cannot apply the limit directly. If you apply the limit directly, it is the denominator is 0, and sin 0 also 0, 0 by 0, then that is an indeterminate form. So we cannot divide 0 with 0. So for that, so here how to show this is, see here. So to show this sin x by x is equals to 1 as x goes to 0, consider a unit circle which is centered at origin. Like consider the unit circle centered at O. So let it be is a unit circle, means the radius of the circle is 1. So this length is 1, this was also 1, 1, 1 like that. Now, so here, so let P is any point on the circumference of the circle. So if we join this origin and that point P, then so this is OP. So this is also length 1, since it represents the radius of the circle O, and this is P. And so from this you can drop a perpendicular line from this point to the x-axis, or so you can drop a line from P to Q, or let it be this is the point R, let it be. Now so you can join these 2 points also on the circle. So this is one more triangle, and so here you can extend this point to outside the circle. So here I am extending this point P to some other point in the plane, let it be it is Q. So extend like this, so up to Q, since there are infinite number of points in the plane, right? So here I am extending this to Q, and so you can join these 2 points also, right? So if we join these 2 points Q and R, you can join these, right? Now so here so you can observe that so O R Q is also a triangle, O P, and let it be this is S, O P S is also a triangle. And so then so this is a line OP that makes an angle with the positive x-axis, let it be it is X, then sign of X is there, so then this is X. Now so here you can observe that R, so let you can consider angle ROP. ROP is X, and so this is lies in the first quadrant, so that compulsory X is between 0 and pi by 2 only. Then so here we will observe, or we can observe that from this figure. So there are 3 figures, so triangle and arc like this. So here ROP is a triangle and ORP is a sector, right? The part of circle ORP is a sector, and the big triangle ORQ is also a triangle. So you can imagine, so the areas of all these 3 figures are, so we don't know the exact values, exact value of all those areas, but so we can write a relation between among these 3, right? See here O R or ROP, ROP triangle, ORP sector, and ORQ triangle, right? Now so here we will observe that the area of triangle ROP, so compulsory less than the area of ORP sector, area of sector ORP, little bit more than that. So ORQ, so it is a POR triangle, and OR e part konjam ekku chudandi, so that so this is more of this, and this is less than the area of this big triangle, the area of the triangle ORQ. Just so you can write the relation among these 3. So we don't know the exact values for all these things, so but we can express so like this. So area of the triangle ROP is less than area of the sector ORP is less than area of the triangle ORQ. And so this implies the area of the triangle ROP. Area of the triangle is of base into height, right? So this is of, here the base is OR. Base is OR. So this is OR into the height of this is PS kada. This triangle chudandi. ROP is a triangle. So base is OR and height is PS. Now, so which is less than area of the sector. So you know the area of sector. Area of the sector is equals to 1 by 2 into R square theta ఉంటుంది. R square theta. R means the radius and theta. So that makes the line that makes at the center of the angle. So it is theta. So area of the sector is of R square. R is nothing but here the radius of the circle, that is 1 unit. So 1 square into theta means x only, which is less than again area of the triangle, right? So this is all same, base into height. Here what is the base for this triangle ORQ? So again the base is OR. So OR into height is QR or RQ. Now, so this is 1 by 2 into, this implies 1 by 2 into OR. OR means this total length. Total length avutundam. So total length is 1 unit into PS. So here, so from the triangle OSP. Here, so already we know that this, and this is an angle X. So by using this right angle triangle, we can express trigonometric ratios, right? Now, so related with this, so మనకు కావాల్సిన ఇక్కడ PS value కావాలి. So PS is nothing but opposite of X. So that is opposite sign. So that we can write a sin X. So sin X is equals to PS divided by hypotenuse is 1. So therefore PS equals to what? Sin X. So here we can replace this PS as sin X, which is less than half into X. 1 square is 1, which is less than 1 by 2 into OR. OR is again 1 unit only into RQ. So again ORQ is a right angle triangle. So here the triangle ORQ. So consider the triangle ORQ. Now ORQ. Here we know this is the length 1 and so this is X. Now so we need to express this RQ in terms of a trigonometric ratio, and so known value is adjacent side of X. So adjacent side known and opposite side is unknown. So we can express opposite side and adjacent. The relation between opposite and adjacent side is tan X. So that tan X can be written as tan X is equals to, now so it is RQ divided by OR. OR is 1. So that RQ value is tan X. RQ is tan X. So that this is tan X. So this implies, so this is sin X by 2 is less than X by 2 is less than tan X by 2. So we have a relation like inequality sin X. So here off is gets cancelled, therefore it is sin X is less than X is less than tan X. Now so we got one relation, sin X is less than X is less than tan X. So sin X less than X is less than tan X. But what we have to find? We need to find sin X by X form. So first so try to get the inequality like sin X by X. So from this, so divide the entire inequality with sin X. Is there any problem? So 0 to pi by 2, sin X is a positive thing, therefore sin X by sin X is 1, which is less than X by sin X. This is less than tan X by sin X. Tan X by sin X. So tan X by sin X can be written as, so tan X means sin by cos, right? Sin X by cos X into 1 by sin X. So sin X gets cancelled, then it is 1 by cos X. So this implies 1 is less than X by sin X is less than 1 by cos X. Now, so here, so we got the function sin x by x in the reverse mode. Now, so we can reciprocate the inequality. Then there is a rule. If a is less than b, then 1 by a is greater than 1 by b. So then reciprocate 1 by 1 is 1 only, and so it will be sin x by x avutundi, and this is 1 by cos x means it is cos x, but the relation will be different, that will be change. So based on this condition, a and b are any two numbers. If a is less than b, this implies 1 by a is greater than 1 by b, right? So already మన functions లో నేర్చుకున్నాం ఇలాంటివి. 1 is less than 2 అనుకోండి, then 1 by 1 is always more than 1 by 2 కదా. So like that. So unknown functions ఉన్న మనకి relation మాత్రం కంపల్సరీ చేంజ్ అవుతుంది when we reciprocate the inequality. And so 1 is greater than sin x by x is greater than cos x, or we can write this as cos x is less than, reverse version, sin x by x is less than 1, right? So here, so the same inequality that is hold in minus pi by 2 0 also, minus pi by 2 0. So the same thing will be hold in minus pi by 2 plus pi by 2. So therefore you can express it as cos x is less than or equal to sin x by x is less than or equals to 1, right? Now, so sin x by x is less than or equals to 1. Now, so this is like f of x is less than or equal to g of x is less than or equal to h of x, right? F is less than or equal to g is less than or equal to h. If the limit of f and g or f and h are same at a particular point, therefore sin x by x or f of x is also same at that particular point by using sandwich theorem, right? Now, so before that, so we need to find the limit for this function and this function. Now evaluate limit x tends to 0 cos x, limit x tends to 0 cos x. So as x is goes to 0, then cos x is what? See, already we know that the graph of cos x, right? And graphically the graph of cos x is so like this. So this is 1. So 0 as x is goes to 0 from left hand side, then f of x is goes to 1. As x is goes to 0 from right hand side, f of x is goes to 1. So therefore limit x tends to 0 cos x is ఏమవుతుంది 1 అవుతుంది. And limit x tends to 0 right hand function 1 is again 1. So cos x is 1 when x goes to 0. 1 is also 1 as x is goes to 0. So hence by the sandwich theorem, what we can express, so the limit of sin x by x as x goes to 0 is also same. Limit x tends to 0 sin x by x is also 1. So hence proved. So 3 more statements are there without proof. So write down those 3 things. So that is theorem 3. That is, so limit x tends to 0, 1 plus x whole to the power of 1 by x is an irrational number. So here so you need to remember this formula. Limit x tends to 0, 1 plus x whole to the power of 1 by x is e. Now in higher classes so we will show then how it will be. So next theorem 4. Then so this is limit x tends to 0. Now it is a to the power of x minus 1 divided by x is, so this is a logarithm of a to the base e, logarithm of a to the base e. And the last one, that is theorem 5. Limit x tends to 0, logarithm of 1 plus x to the base e by x is 1. So these are 3 more theorems, so without proof. But also you need to remember these three formulas. And so one more thing, so you need to note, that is number 1. So limit x tends to 0, cos x value is equals to 1. So by using graph, so just now we showed. Number 2, if a is any number greater than 0 and n is a real number, then limit x tends to a, x to the power of n is directly a to the power of n, since we know that x power n is a nth degree polynomial. And number 3, limit x tends to 0, here e to the power of x minus 1 divided by x is equals to 1. Right? See, already you know the theorem 4. So here a is replaced with e, then what happens? So it is a log e base e. Log e base e is nothing but 1. So that's why, so it is 1. So remember, so all these things. So in the next lecture, so we will see the problems on these standard limits.